All right, we're going to talk about inverses of matrices. So remember, inverses are kind of like items that are opposite. They kind of work backwards. The one thing we've got to look at is when we're looking at inverses, we have to understand what the identity means. So the identity matrix is this matrix with ones down the principal diagonal and everything else is zeros. Okay, so our example here is 1, 0, 0, 0, out to infinity, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0. And the bottom right corner is going to be a 1, and we want ones all down there. Well, anytime we have an identity matrix, the nice thing about identity matrices is that when we multiply, so if I take A times the identity, I get the identity times A, which is A. So I get back to my original. All right. So if I were to multiply this matrix 4, -7, -3, 2 times the identity matrix, I end up getting the exact same matrix. Okay. So that's the nice thing about the identity matrix. It gets us back to our original item. Okay. Now, when we're talking about the inverse, we have to talk about this idea of determinant, okay? So a determinant is a single value that represents the square matrix. So we only have determinants of 2 by 2 matrices, 3 by 3, 4 by 4, 5 by 5, so on and so forth. All right? So I'm going to show you a 2 by 2, how to find a 2 by 2 matrix, and then we'll talk about a 3 by 3 matrix and kind of expand on that idea. So there's a couple of ways to write determinant. So you'll see DET standing for determinant of the matrix. So A, B, C, D. You'll see it almost looks like it's an absolute value of this, but you'll see vertical bars with the matrix inside of it. And then what we do to find the determinant is I take my principal diagonal minus my secondary diagonal. So I'd have AB minus BC. So here, if I want to find the determinant of A, and A is 1, 8, 3, 6. What I'm going to do is I'm going to take 1 times 6 minus 3 times 8. Well, that gives me 6 minus 24, which is -18. -18 is the single value that represents this matrix. Okay. Now we have a 3 by 3. So the 2 by 2 is pretty straightforward. We're just multiplying the diagonals, finding the difference. Primary diagonal, secondary diagonal. Now in a 3 by 3, it becomes a little bit bigger problem. So what we do is we're going to look at breaking this down into smaller pieces, and this is how we do it if we're getting to a 4 by 4, a 5 by 5, so on and so forth. So what we're going to do is we're going to look at taking our first row and then finding the determinant of what's left over. Okay? So the determinant of a 3 by 3 is A times the determinant of E, F, I, H. Minus B times the determinant of D, F, G, I, plus C times the determinant of D, E, make sure that looks like an E, G, H. Now, the way we find this is we take our first row. So A here, we look here, well, here's the row and column. So those go away. There's my determinant that I'm going to find. I'm going to take A times the determinant of EF. So if I was finding B, I would have B, I would circle this, and now that row that B is in and the column B is in kind of get weeded out, and now I have the determinant of D, F, G, I. All right? Okay? And it always alternates. Positive, minus, okay? And so then I would find the determinant of each of these, multiply it by A, find the determinant here, multiply it by B, subtract it, find the determinant here, multiply by C. So here I have the determinant of 1, 2, 3, -1, 0, 5, -2, 4, 6. So I'm going to split this up into smaller determinants. So I'm going to take 1, okay, so I get rid of that row and that column. There's my other determinant, so 0, 5, 4, 6. minus 2 times the determinant of negative 1, 5, negative 2, 6, plus 3 times the determinant of negative 1, 0, negative 2, 4. So now I have 2 by 2 determinants. I can find those fairly easy, so I'm going to multiply principal diagonal minus secondary diagonal. So on the first one I have 1 times 0 minus 20, minus 2 times negative 6, minus negative 10, which gives me plus 10, plus 3 times the quantity negative 4, plus 0. So I get negative 20, negative 8, negative 12 for a grand total of negative 40. This process is how we would have to handle 3 by 3s, 4 by 4s, 5 by 5s. So if I had a 4 by 4 here, and we're just going to kind of put this, we're not going to find it here. So, and we're just going to find the first one. So let's say I have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So there's my 4 by 4. So the first one would be A times the determinant. So I would get rid of this column, this row of F, G, H, J, K, L, N, O, P. And now I would have to take A times, and I would have to split this up into those smaller 2 by 2. And I'd have to keep doing that. Okay? So now that we understand determinants, what we're going to do is we're going to look at inverses. So if I have A, and I'm going to multiply that by A inverse, what that's going to do is that's going to give me my identity. Okay? Or if I have A inverse times matrix A, that's also going to give me my identity. So the product of my matrix and its inverse is going to get me back to the identity. Well, there's a quick approach for a 2 by 2 inverse. Okay, so 2 by 2 inverses are pretty quick to find. So what we're going to do is if I have matrix A and it's A, B, C, D, what I'm going to do is to find my inverse here, inverse A, I'm going to find the determinant first. So I'm going to go 1 over the determinant of A times this new matrix. And what happens is I take my principal diagonal and I'm going to interchange that. So it's going to be D up in the top left, A in the bottom right. And then I'm going to negate my secondary diagonal. Okay? So here I have A is equal to 5, 6, 3, 2. First thing I want to do is if I want to find A inverse, find my determinant. 5 times 2 minus 3 times 6, that gives me negative 8. Okay? That's good. So now my inverse is 1 over negative 8 times the quantity. So I interchange the 2 and 5, 2 and 5, and I negate my secondary. So 2, negative 6, negative 3, 5. There's my inverse. I could multiply in this negative 1/8 and find this in fractions. I'm going to leave it like this. That's fine. Now, that's for a 2 by 2. If we have anything larger, what we have to do is we have to go back to that idea of solving a matrix. Okay? And so what we're going to do is I'm going to put my matrix here. So here's my original matrix. Is I have negative 2, 3, negative 3, 4. Okay? So A, in this case, is this, right? So A equals negative 2, 3, negative 3, 4. There's my matrix. Okay? So if you remember, A times A inverse is going to give me the identity. And so what I'm going to do is I'm going to take my matrix here, and I'm going to have here's my original matrix, here's my identity. Okay? And so what I'm going to do is I'm going to make this side, the left side of that, the identity, and the right side then is going to be my inverse. So the first thing I'm going to do is I'm going to come here and I'm going to divide my first row by negative 2. So I can get a 1 in my very first location here. So I divide everything here in the first row by negative 2. So I get 1, negative 3 halves, negative 1 half, 0. I rewrite my second row. Okay? Now what I'm going to do is I'm going to multiply my first row by a value and add it to my second row to get rid of negative 3. So I'm going to multiply the top row by 3, add it to the second row. Okay, so this becomes 1 times 3 is 3, minus 3 is 0. I want this to be 0. Okay? So now I'm multiplying this by 3. Gives me negative 9 halves plus 4, which is 8 halves. So negative 9 halves plus 8 halves gives me negative a half. So my first row is just rewritten. Negative a half times 3 is negative 3 halves plus 0 is negative 3 halves. And then 0 plus 1 is 1. Okay? Now, I need to get this spot right here. So row 2, column 2, I need to get that to be a 1. So I'm going to multiply the second row by a value to make it 1. Well, since it's negative a half, I'm multiplying everything by negative 2. So I'm going to multiply the second row by negative 2, rewrite my first row. So I just rewrite my first row, 1, negative 3 halves, negative a half, 0, 0. So I multiplied by negative 2, that gives me 1, 3, negative 2. Now, I have to get row 1, column 2 slot to be 0. So I'm going to multiply my bottom row by 3 halves, add it to my top row, so that way I can have 1, 0, 0, 1. And then when I do that, I'm going to multiply by 3 halves. So 3 halves times 3 is 9 halves. 9 halves minus half is 4 halves, which is 4. I multiply negative 2 by 3 halves. I get negative 6 halves, which gives me negative 3. And then I rewrite my second row. So this is my inverse here. A inverse is 4, negative 3, 3, negative 2. There's my inverse. Now, I showed you this on a 2 by 2. If you have a 3 by 3, you can't use this approach. You have to use this approach here. Okay, so you're going to have to use this on a 3 by 3, a 4 by 4, a 5 by 5. So that is a how we find inverses, how we find determinants, how we use determinants in our 2 by 2 inverse.